So just to go back to this question to make sure you got the same thing I was hoping for, what does it mean to graph a system of equations? Again, the sort of graph it idea means you're graphing the solution, and maybe I should write ordered pair solution or solutions that satisfy all equations in the system, right? So suddenly now we're really looking for some solution, some order pair solution that makes all the equations true. Okay. Okay. So now after you read page 271, hopefully you saw that there's really three possibilities for systems for equations of two linear equations with two variables, right? We are eventually going to see more than two, but if we just have two lines, so here's a line, whatever it looks like, they either could intersect at one point, okay? And so that's the one solution. So again, let's talk about why that's one solution. So remember, what are we graphing when we're graphing a system of linear equations? We're graphing all of the points that make the equation true. So on this line, all of the points along this line make this one equation true. And then all these points along this different line make this equation true. So where is the one unique place where the equation is that both equations are true? Is that one single intersection, right? So the intersection is the solution to the system because it is the unique one place that makes both simultaneously this equation true and this equation true. If the two lines never intersect, so if they're parallel, and that is a really bad graph of parallel lines, so they never intersect, we're going to have no solution, which we could write as the empty set right there. Okay, and why is that true? Why is it that there's no solution? Well, I have all these infinitely many ordered pairs along this line that make this equation true, and then I have all infinitely many ordered pairs along this line that make this equation true, but there is no overlap. There is no single point that would simultaneously make this equation true and this one true, right? There's no solution. And then the other possibility is that when I draw both lines, in fact, the graphs of them are simultaneously both exactly the same graph. So these are when the equation really gives the same line. So there is infinitely many solutions, and those solutions are all ordered pairs that satisfy. So say the equation was of the form ax plus by equals c, it would be all xy that satisfy that equation. Right? So what's happening here is I have all infinitely many points that satisfy this first line, and in fact those are exactly all infinitely many points that satisfy the second line. They are in fact exactly the same. So, but why are there no other possibilities, right? Well, I'm talking about two linear equations, right? So they have to be lines. So I can't have things like here's one curve or parabola or something, and then here's another curve, another parabola. If I were looking at a system of two quadratic equations in two variables, suddenly we could have more options because I see 2 points here that will simultaneously make both those equations true, right? So, but the fact that these are linear means we can't have them curving back around. The only three visual possibilities would be a single intersection, no intersections, or infinitely many intersections. Okay, so those are our three possibilities for solving a system of linear equations.